All right, good evening. Hello, it's a pleasure having you here. Thank you for taking the time, being interested at Bees Without Borders conference. Those Bees Without Borders conferences we started in a partnership together with Honeybee Wild in Luxembourg, Apis arborea in the US, and the Natural Beekeeping Trust in the UK. And we, that means FreeTheBees in Switzerland. And my name is André Wermelinger. I was the founder of FreeTheBees and the CEO and your ceremony master tonight. And what we want to achieve with those monthly Bees Without Borders conferences is it aims at all the pollinators. It aims to understand better the bees in the natural environment and all the connections between bees and the whole ecology. And so I'm really happy to introduce Przemek Nawrocki from Poland. And we met some years ago in 2014 when Hartmut Jungius, who is present here and listens to the conference, Hartmut Jungius, he called me one day and asked me why we wouldn't introduce the tree beekeeping in Switzerland. And I found the idea so great that some weeks later, I visited Przemek in Poland to see what they did. Really amazing and great job. And Przemek invited us, and we had some 2 or 3 very good days. Ran around the whole country, looking at every trees with bees. It was very interesting. And then we started lots of new things. We started with international courses, introduced the tree beekeeping to Switzerland, and somehow exported it to Germany, to the UK, to France, to Belgium, Luxembourg. There are people being very interested in the north of Europe. So really a big story. Lots of tree beekeepers being able to do this very interesting craft. So Przemek, nice having you here. Thank you a lot. And I hope that you say some words about you. I think you know much better who you are than whatever I could introduce.
Hello, everyone. I am very happy to be a guest of FreeTheBees and Bees Without the Borders again, as last year, together with Hartmut, we had a presentation on tree beekeeping restoration in Europe. And this time, I would like to present you in details some experience which we collected during 15 years in one forest in Poland. So let me start sharing the screen. I would like to show you some slides.
Przemek, one question, would you like, or do you prefer having questions directly, or would you like to get the questions after your presentation?
I think it's up to you.
However, whatever you prefer, I don't mind. We are not such a big group. People know now that we record the sessions, and they look in a much bigger number afterwards. So I think we can handle questions in the chat, or directly you just open your microphone and you ask.
I guess that this is a good idea, as we are not very numerous, so that means that we may be able both to answer the question meantime and to complete the presentation. So let's try this way.
Good, thank you.
Okay, so the title of the presentation is Potential of tree beekeeping as a tool for protecting the population of wild honeybee. And this is summary of 15 years of experience from the Puszcza Pilicka Forest in Poland. I would like to present to you experience of three of us. That means Tomasz Dzierżanowski, who is with us today, Andrzej Pazura, whom many of you may know from tree beekeeping courses, and my own experience in attempt to introduce tree beekeeping as a tool to protect free-living honeybee population. I guess that the majority of you today are beekeepers, but I think you would be interested in looking at different angle at honeybee, not as the animal which we keep in apiaries, but as a wild species which may need equal attention as large carnivores. As in many countries, perhaps honeybee meets the IUCN Red List requirements. The status in particular countries of these various species can be either endangered, critically endangered, locally extinct in the wild, and officially, all over the Europe, the status of European honeybee is data deficient. That means that we have lack of precise information about its situation, but at the same time, this status, data deficient, doesn't mean that we cannot consider such a species like honeybee not endangered, only because we do not have enough data. That we already know about it is that population of free-living honeybee populations in forest are in poor condition, and their situation is comparable to the situation of large carnivore species like lynx, wolves, or brown bear. And it will be interesting to answer question, why is this happening? But before we will go to these matters, I will start from basic terminology. First, what we will call particular nesting sites of the honeybee. Honeybee colony occupying natural hole in a tree, I will call natural hole or a bee nest. While tree beehive, this is a man-made hollow in a tree, accordingly to ancient technique, which is about 2,000 years old, or maybe even older. The hollow is made in a live tree, usually in pine or in oak, and seldom in some other species. Tree hive we can see on this photo from the left side on the screen, while log hive, tree log hive, it's a structure which is very similar inside, like tree hive. This internal structure is actually identical. The only difference is that log hive is made out of chunk of a tree trunk and then installed high on a tree. So while using term log hive, I will mean this type of hive which is high on a tree, not standing on the ground, because other option to use log hive is to put it in apiary in the similar manner like regular beehives. And the tree beekeeping, this is a term which we actually had to create because in English language there was no any ready term for that. It's a craft or caring for bees inhabiting this type of ancient hives, tree hives or tree log hives. Prostitution of tree beekeeping in Poland and Europe started in 2006. It was initiated by WWF Poland and completed in cooperation with WWF Russia, unfortunately non-existing any longer in Russia because of the war. We have tremendous help provided by beekeepers from Bashkortostan, southern Ural, rangers from Shulgan-Tarza-Powiednik, where beekeeping as an ancient craft survived in intact form many generations since actually the beginning of this craft among Bashkir people, without any break. While in Poland, we lost this beekeeping tradition about 100 years ago. So help from beekeepers from Bashkortostan was extremely important because beekeepers from this distant country could add oral tradition, that is what we just lost in Poland, to book knowledge and museum specimens. So they intended to share with us knowledge about modern beekeeping because we didn't want to restore a kind of a live museum, but to learn from them how to use modern tools in tree beekeeping like chainsaw and in which circumstances we may need all these traditional tools which may have 2,000-year-old tradition, like specific type of chisels, axes, and etc. Several tree beekeepers in Poland were created that way, I would say. They were beekeepers which passed through comprehensive training. And among these lucky beekeepers were Andrzej and Tomek, who are co-authors of this presentation. And since this project in 2006, we started spreading knowledge of beekeeping in Poland and abroad. That is what Andrzej just mentioned about his visit to Poland and then this idea to bring this knowledge to Switzerland and other Western countries. And for me, while talking about it, it's always great to mention all these great people, their names: Tatiana, Firdaus, Zilia, Hartmut, who is with us, Mikhail, Achtiam, Rais, Ramazan, and other great people who were helping us in restoring this ancient craft with aim to restore unique tradition and also to help nature, to help restore free living population of honeybee. After this already 16 years, we have in Poland more than 100 tree hives and 75 log hives, these tree log hives, of course, spread all over the Poland. This red circle indicates tree hives, blue log hives. This is inventory made by Tomek Dzierżanowski. But it's worth to mention that these scattered dots, these are mostly results of work of single enthusiasts of tree beekeeping sometimes NGOs oriented on restoring this vanished craft, sometimes state forests. But on the map of Poland, there is also one very interesting spot, the project Beekeeper of the Sudetes Mountains, implemented by Polish State Forest, where 1,000 tree logs were installed at once. That is even more than in this Shulgantash Zapowiednik in Russia, which was designed to protect free-living honeybee. So this is very interesting place and unique on the scale of the whole Europe, these beekeepers of the Sudeten Mountains. The forest and the clusters of tree hives and log hives I would like to talk about tonight is located here, right in the middle of Poland, on the lowland part of Poland, where we have all together in this so-called Puszcza Pilicka Forest. First of all, worth to mention that we have quite big chunk of forest, 52,000 hectares of managed forest, which is comparable in size to the largest Polish national park. And what is typical for lowland Europe, 90% of these forests are coniferous trees, mostly pine. Only 10% these are deciduous broad-leaved forests. During these 15 years, we managed to build, at the beginning with help of our Bashkir master and then with our own effort, 34 tree hives, 5 tree log hives, and we have already behind us 16 years of observations, annually between 7 to 28 tree hives and tree log hives. We observed during this time 124 colonies, up to 16 colonies per year. And we also recorded 110 colony wintering. We ran a sort of citizen science project, that means database on tree hives and tree log hives. And this database would allow us to present you some, I hope, interesting results of observation, what is happening with bees in these tree hives and log hives in the first forest when we try to restore tree beekeeping. Andrzej has 10 tree hives, 3 log hives, Tomek 14 tree hives, 2 tree log hives, and I have symbolic 1 tree hive. That is distribution of these hives in Pilicka Forest. We can see that they are not even. They are clustered to some extent that illustrates the distribution of available trees thick enough to build a tree hive in them, and to some extent activities, patterns of particular tree beekeepers. Here we would like to show you how number of the tree hives and log hives change over these years, and how frequently they were occupied by colonies of honeybees. The blue columns shows number of hives, while this orange line shows what was the number of bee colonies in these hives in particular year. And we can see that contrary to that what we know from apiaries, quite a big section of these tree hives and log hives were not occupied. On average, we had around 46% of tree hives and log hives annually occupied by bees. I would like to comment on this red arrow, which indicates decrease of number of trees, the tree and log hives. And this is a very important year for us because we decided to stop using some of these tree hives to avoid too high density of colonies in order to reduce competition for food and therefore increase chances of the colonies to survive. This graph shows particular locations. The number like B8 on x-axis, this is a code for particular tree hive or a log hive. The blue column this time indicates number of years the given hive exists, while this orange line indicates how many years this particular hive was occupied by bees. And we can see that particular hives differ quite strongly in terms of share of the years they were used by bees, between 12 up to nearly 90% of the years. And generally, the conclusion is that these tree hives, as we expected, are eagerly colonized by free-living honeybee colonies and may effectively compensate for the shortage of natural hollows. And as I mentioned, they differ in terms of frequency by colonization. We are not exactly sure why yet. That will be subject of our further studies. What was the reason why some sites seems to be much better than some other? And now a very important question. Can tree beekeeping bring honey? On this graph, we can see that we, during these 15 years, had altogether equivalent of 134 hives. That means that we had, in theory, all these hives available for honey harvest, but it turned out that only out of 14 we can get a little bit of honey, and usually they were symbolic amounts, maximum 2 kilograms. That means that in this very situation of this commercially used forest, which may be also applicable for quite big areas in Europe, currently it is not possible to return to profession of a tree beekeeper who obtains significant income from honey production. And it is worth to mention that in Ural, it still works that way, that tree beekeeper can earn quite good money out of keeping bees in tree hives. 1 kilo of honey in Ural costs 50 euros from tree hive, while in Moscow even 200 euros. So, at least in Poland, nowadays, the main motivation to practice tree beekeeping is protection of cultural heritage or nature conservation. But that means that motivation is different, but at the same time, it's still possible to earn money out of tree beekeeping in different way. For instance, by giving a beekeeping show. Here you can see an advertisement on one of Polish tree beekeeper who offers such a show for 140 euros. Presenting on traditional climbing techniques, way of caring for a tree hive. And I think for several hours of work, it's a quite good money. But from other hand, I must admit that using this traditional way of climbing trees, it's a really sophisticated craft and it's a very dangerous job. I wouldn't recommend it unless you would like to earn good money or risk your life. Now, forms of care for tree hives and tree log hives in the Puszcza Pilicka Forest. Varroa treatment we used only during early years, and we quickly decided not to continue. That means that Varroa treatment we can consider negligible. While following example from Ural, we allowed artificial feeding before wintering to give better chance for bees, especially young colonies. That means the swarms will just settle down to winter. And depends on the beekeeper. The feeding was either extensive, about 2 to 3 kilograms of sugar before wintering, or we call intensive, 5 to 6 kilograms before wintering. Only colonies that in the tree beekeeper's opinion were too weak or that they didn't have enough honey to survive were artificially fed. So altogether, we had more than 1/3 of colonies supported by artificial feeding. 70 wintering without feeding, and 40 wintering of colonies with some extra feeding. That is distribution of final age of honeybee colony. We had chance during these 15 years to observe 67 colonies, which we known from the beginning, from the moment when the swarm established itself, inhabited tree hive or log hive until the colony died out. What is interesting that we have very huge share of colonies which didn't survive winter. We used the number of winters as a measure of age of the colony. 0 winters means a colony which didn't survive the winter. From other hand, it is normal because in every animal, the young individuals have usually the highest mortality. It's true among birds, among wolves. Generally, it's basic biological rules that young individuals have the biggest mortality. What is also interesting that we can see on this graph that we had already during this first 15 years several colonies which survived quite substantial number of winters. We have 2 colonies which survived 6 winters and 2 colonies which survived 5 winters. Among these record holders, the colonies which survived 6 winters is a colony in this oak tree presented in the photo. What is interesting, it was located very close to hornet nests, and hornets regularly preyed on the bees. 6 winters as the terminal age of a colony seems to be good result, having in mind that there was a common opinion in Poland that bees without Varroa treatment may not survive longer than 2 years, while we have proved that they can survive even 6 winters. So this is good news. But the bad news is that we have 6 winters in our population of bee colonies as the best results, while in Arnold Forest, the famous forest studied by Professor Schiele, where the subject of his study were free-living honeybees in American forest, 6 winters was an average age of colonies which survived the first winter. That means that we have much shorter longevity of honeybee colonies that in prime conditions, like for instance in this Arnold forest, and perhaps in Ural as well. All this information about survival of bees, their ability to survive winter, allowed us to prepare a graph which shows what is the chance of surviving consecutive winter by a given colony. And as you can see on this graph, which shows wintering with artificial feeding, the chance to survive the first winter is only 40%, while, for instance, the fourth winter is already above 80%. And surviving fifth and sixth winter is a little bit lower, but here I must admit that we didn't have much data. But anyway, it shows that the older the colony is, up to the age of 4 winters, the better is survival rate. Based on this data, we can also try to guess so-called worst-case scenario or black scenario. What would happen if we didn't feed the bees, the colonies before wintering? This situation illustrates this graph with black columns. We assume that while preparing this graph that each colony which was fed because beekeeper decided that it's too weak to survive would die without feeding. And that assumption gives this graph with black columns. When we compare the two of them, we can see that this sugar feeding, or ideally honey feeding, may significantly increase the success of the first, especially the first, the second, and also the third wintering. And this is perhaps very important from the perspective of improving chances of survival of these free-living bee colonies in forest conditions. What is also interesting that this data, which we collected based on this 110 wintering, is enough to build a sort of small and simple model which allows us to answer several important questions. Can a population of free-living honeybee colonies in tree hives and tree hive be self-sustaining? That means, can this population survive without any more help of the human being than some extra feeding, or maybe can survive without this extra feeding? And also we can ask ourselves, how many colonies will we have after 30 years if we start with 50 tree and log hives populated with 50 artificial swarms? That is a situation maybe ideal where we have enough financial resources. We build 50 tree and log hives somewhere in a forest, and we have artificial swarms, for instance, representing lineages of primitive bees from any project of preserving genetic diversity of these traditional bee lineages. And then we can try to answer these questions building simple model of honeybee population dynamics. And we built such a model having two assumptions for modeling. First assumption is that the wintering success of the colonies in this model is similar to that in the Puszcza Pilicka Forest, that what you could see on these two graphs which I presented to you earlier. And the second assumption is that every second colony in tree hives and log hives in the forest older than one winter produces one successful swarm per year. Successful swarm, that means swarm that will inhabit empty tree hive or tree log hive. And that assumption means that there will be 0.5 swarms on average per colony per year. And now we can see what the modeling will tell us, having in mind this famous saying about models. This is a quote from a famous statistician, George Box. All models are wrong, but some are useful. So let's hope that our model, being of course wrong, may give us some useful answers. First, let's start from worst case scenario. What will happen to the population of these 50 colonies within 30 years? That means one human generation time. This is the graph. The blue line on this graph shows numbers of bee colonies predicted by the model. And results looks rather very pessimistic. That means that these 50 colonies will die out within 5 years. That means in this situation where the bees will be left alone, we will not feed them before winter. And now let's see how this optimistic scenario may look like. That means we have this artificial feeding before wintering in the cases where we feel that the feeding is necessary. And this is the result produced by the model. Again, the population will go extinct. But this time, even with feeding, the population will die out in the period of about 10 years. That means that without immigration from inside, from potentially from apiaries or from swarms from natural tree holes, this population of bee colonies in tree hives and log hives will not be able to survive. What is important here is that most likely population in these natural holes will have even more difficult situation because tree hive is usually safe from predators like pine martens, like woodpeckers, while majority of potentially available holes in forests, these are holes which were initiated usually by woodpeckers. That means that birds like chickadees, tits, woodpeckers, and pine marten, when the hole is made by black woodpecker, all these predators can easily access colony. That means here that chances for survival of free living colony of honeybees in forests are rather small. And now we can look at a different situation and ask different question. How many colonies will we have after 30 years if we start with 50 empty tree and log hives, populated with natural swarms from the forest, that means from bees occupying natural holes in trees, and swarms from apiaries. And again, we will start from worst scenario, assuming in our model that on average we will have 6 swarms from apiaries and 2 swarms from natural treehouse. And here is the result. The model indicates that in such case, having that strong immigration from outside to the forest and from inside the forest, and reproduction rate of 0.5 swarm per year, the population of bees will establish on a little bit above 10 colonies per year. This blue line on the graph. This dashed line indicates upper and lower limit of prediction. That means that the model assumes that the numbers of bee may fluctuate in a range between the lower line, dashed line, up to the upper line. And how situation will look like in this optimistic scenario. By the way, one more information. The model also informs us that in such case, our population which occupies tree hives and tree log hives will be pretty young. That means 82% of the population will be colonies of 0 age. That means those which didn't winter yet. Only 18% colonies which survived minimum 1 winter. And now the optimistic scenario, that means that we add some artificial feeding to the colonies. In this case, situation is a bit better. That means that in about 10 years, the population of honeybee colonies in tree hives and log hives will establish itself on the level of about 20, and within a range between 12 to nearly 30. So it's not bad. The age structure will be a bit different than in this worst case scenario. 30% of these bee colonies will be of age minimum 1 year. Still, young colonies will dominate, 60%. And we can also imagine even more optimistic scenario, that we will increase swarming rate of bee colonies inhabiting tree hives and tree log hives. So we can achieve that, for instance, by reducing size of the hives to, for instance, approximately 35 liters. And also, we may hope that with time, the colonies which will inhabit tree hives and tree log hives in the forest may have more tendency to swarm, that under pressure of natural selection, they will be more eager to swarm in comparison to domesticated bees, where a lot of effort or beekeeper is focused on suppressing swarming. And this optimistic scenario, with 1 successful swarm per forest colony per year, we have very interesting result that in such case, within 30 years, we may expect population which will establish itself on the level above 45 colonies annually. And with the upper limit of the model, will trespass even 50 colonies, and the lower limit 25. The model gives us also information about the structure, age structure. Will be similar like in this earlier case, 60% of young colonies, 40% of colonies in reproductive age, because we assume that only colonies older than 0 winter, that means 1 winter, 2, and so on, will produce swarms. The report from the modeling shown here leads to several conclusions. That first of all, the very basic, that free-living colonies and colonies and apiaries, as well as natural hosts, should be recognized as one metapopulation, that we cannot hope for separating free-living colonies and colonies from apiary. They should be seen as one population. The arrow in this model protocol indicates that we will have relatively low numbers of colonies in the forest which are at reproductive age. That means they are able to swarm. Out of these 46 colonies on average annually, only 19 will be able to reproduce. That means that we are far away from safe number of 50 colonies at reproductive age. This 50, it's a kind of magic number in nature conservation. It is usually assumed that if we have endangered species, the minimum number of reproducing individuals must be 50. So in this case, if we have that in mind, the next conclusion is that we need to have, in this very optimistic scenario, 120 colonies per year on average, in order to achieve this 50 colonies at reproductive age. And that means that we need minimum 200 trees and log hives, and available forest area to accommodate these tree hives and log hives in low density of 25 by 50 kilometers. That means enormous chunk of land and enormous challenge. So, coming back to this famous saying, all models are wrong, but this useful information for us from this modeling is that restoring free-living population of honeybee in forest will not be an easy task. That's for sure. And now, how a real life meets the prediction of the model. How the population size of free-living honeybee colonies in the Puszcza Pilicka Forest looks in comparison to the model prediction. On this graph, the blue line represents the number of colonies from the very beginning of our work in 2007 up to 2022. These blue lines is not even, of course, and this orange line represents the average predicted by the model, and dashed lines upper and lower limits of numbers predicted by the modeling. And it seems that actual population dynamics of honeybee in our forest meets relatively well prediction of the model for 4 swarms per year on average, coming to our tree hives from either apiaries or from bees inhabiting natural hollows. What is also important, that the model predicts that in 30 years, if nothing changes in terms of success of wintering, available food in the forest, and the level of immigration of swarms from outside, we can expect that our population on average will be only 11 colonies annually, within range from 7 to 14, and that we have only 4 on average, 4 colonies of reproductive age. So the useful information for us is that our population, seen from the perspective of nature conservation, should be considered as rather small, and at the same time, being so small, also in risk of extinction during any, for instance, cases like bad weather in particular spring, etc. So such population in nature conservation usually is considered not safe. What is also good to know, useful information for us, that if nothing changes in our population, we shouldn't expect bee colonies older than 3 winters. This is the graph shows that we will have a domination of colonies in 0 age, 1 winter and 2 winters, but chances for colonies older than 5 winter will be really, really slim. Now we can try to answer the question of potential source of swarms for bee colonies inhabiting population of tree hives and log hives. And one of the best potential source of swarms are, of course, natural hollows. We decided to look for such colonies using bee lining, the technique which was used as a scientist now and earlier was very common in Northern America for harvesting honey. It's based on catching foraging bees, marking them individually, feeding them with very attractive food, creating situation when they believe that they are robbing a hive, and then recording direction of the flight, recording time which takes between the bee between the feeding, going to the nest and returning back with companions to feed on this extra food. We learned this technique from this famous book, Following the Wild Bees by Professor Tom Seeley. And we had beginner's luck because during the first try at the first day, we found a tree hole occupied by bees, and altogether we found 2. That means that we have proof that bees which inhabit natural cavities in trees really exist in Puszcza Pilicka Forest, and then potentially could provide good quality swarms. Good quality, that means swarms which may be produced by bee colonies which are under pressure of natural selection and may have, because of that, right genetic and epigenetic makeup, allowing them successfully exist in forest conditions, like locating scattered food resources, long ranges of flights for looking for right location for new swarms, etc. All these features which are suppressed to some extent in apiaries by beekeepers, which usually expect something different from the bees, relying, for instance, on easy to access food resources very close to apiary. And now another potential source of swarms, apiaries. On this map, you can see Puszcza Pilicka Forest, the same map which I presented earlier with 3 hives. but on a little bit larger scale. These blue dots, these are apiaries, and this orange ring around them indicates a 2.5 kilometer buffer, which we assume this is a zone of potential competition for food with free-living bees. So, as you can see, there are plenty of them, and we have direct proof that they deliver swarms to our tree hives. The photo of the queen with plastic badge, which we found in one of our tree hives, is the best example of that. But I would like to stress out also this situation indicated by these arrows, that very few areas in Puszcza Pilicka Forest are not affected by competition for food from the side of bees from apiaries. And the conclusion is that apiaries are perhaps major source of swarms due to the huge numbers around the Puszcza Pilicka Forest, but at the same time, perhaps very small fragments of Pilicka forest are not affected by bees from apiaries in this negative way. It was to mention that tree beekeeping as a profession, a golden age of tree beekeeping, was associated with a forest of a distant past, which we already do not remember. That was a forest shaped by agriculture in Europe very early, actually from the Neolithic era to 19th century. And this word forest in many languages means not necessarily forest in that shape as we understand now. Forest, it was simply unmanaged land which had a very mosaic character. It actually looked more like savanna, African savanna, than modern forest, and had many functions. It was a pasture of domestic animals, source of hay, acorns, firewood, and what is important, that many weaker soil, that sandy soils, for instance, were covered by heather, which was a result of grazing of sheep, cows, horses, and frequent fires. And that type of forest, it was really excellent habitat for honeybees. That was forest for honeybees and tree beekeepers and its best. It's interesting to compare how such forest looks like in comparison with modern day forest. Very interesting example give Puszcza Augustowska in northern Poland. In up to 19th century, the tree canopy in this forest, based on historic record, covered only 60% of the areas, and amount of wood per hectare was estimated on 160 cubic meters, while nowadays the tree canopy covers 100% of the area, and the amount of wood per hectare is much larger, actually twice as large as in 19th century. And that means that this type of forest, which is represented on this schematic picture on the illustration, was replaced by something completely different, by forest focused on timber production, with reduced number of species of trees and age classes of tree, with high ground cover and overrepresentation of coniferous species, especially pine and spruce, with small amount of lime tree, which is very important from the perspective of bees, and also shortage of old hollow trees, as what is missing in the modern forest are the oldest age groups of trees. And such huge oaks which we sometimes can see in this commercially used forest with spreading crowns in very dense forest. These are the last remnants of this forest of the past, which doesn't exist any longer. And this new forest obviously is not bee friendly. And this is one of the reasons why, apart from all these potential changes in genetic and behavioral abilities of swarms which escape from apiaries, the lack of good cavities in the forest and lack of food for bee colonies is responsible for problems which we have with very low survival of colonies nowadays. And now let's try to imagine how we can start searching for population of free-living honeybees, if we have in mind that one of our goals is to find such a place, such a population, and support it with tree beekeeping as a tool which may compensate at least for one lacking element, lacking feature of the old forest. That means with tree beekeeping we can compensate for shortage of good cavities. So we can imagine that we start in ideal world from the chunk of the forest which is 25 by 25 square kilometers with some wilderness area inside. That means area with no roads and no building. That means place where apiary cannot be taken. Place left for entirely for wild animals, including wild honeybees. And this size of the area, it's approximately 1/4 of that area which I mentioned earlier, which may be necessary for creating viable, that means large enough to survive a long years population of 50 reproducing colonies. So the first step in such search for free-living honeybee population will be assessing capacity of forest areas, especially within protected areas like National Park, Natura 2000 site, and also outside in commercial forest. And we, having in mind that we find such a forest, first of all, we should locate apiaries and determine so-called avoidance zones. These avoidance zones will be delimited by a range of drone flights, and this is the dashed circle around apiary, and range of foraging bees, that is this smaller circle. And having in mind that we have a piece of forest not affected by apiaries, we will concentrate first on this area, especially this core zone without bees from apiaries and not affected by stationary apiaries. The first step of assessing the situation should be focused on locating white colonies in summer using these bee hunting techniques I mentioned earlier. And after locating trees with hollows occupied by bees, which is represented on this graph by these yellow circles, we can identify gap areas. That means potential location of tree and log hives to compensate for the lack of natural cavities. Having done that, we may build tree hives as a first step towards providing this wild population or free-living population of honeybee new extra breeding sites. why to start from tree hives? Because usually the limiting factor is lack of good trees. So we should claim as quickly as possible right trees by building hives in them to avoid cutting them, for instance. And the next step in building strong, viable, free-living honeybee population will be adding log hives in places where we can find good conditions, potential good foraging grounds, not far away from permanent source of water, etc. And in this case, in this example, we can that way achieve 38 nesting sites, among them 14 wild colonies in natural nesting sites and 24 artificial, that means tree hives, and 3 log hives. What is very important that the distance from the hollow inhabited by bees and the distance between the tree and log hives, which we intend to put into this forest, initially should be approximately 2.5 kilometers. That's a big distance, is similar to that what is recorded in low density populations of free-living honeybees in Europe nowadays, and it may be that density which is optimal for this low food level nowadays forest. And eventually we may increase the density of the tree hives and log hives, but the distance should be no less than 1 kilometer. From one hand, to avoid competition between colonies inhabiting this tree, and from other hand, allow them easily find such location to establish a new swarm. But first of all, we should start from very low densities and observe what happens, and then decide to add or not to add more hives. Next step, and actually a step which should be completed at the very beginning of the project, is cooperation with local beekeepers. The very basic condition is to agree with local beekeepers to stop varroa treatment. Otherwise, the swarms escaping from apiaries will bring to the forest sensitivity to this pathogen, and this free-living population will never be able to develop natural resistance to varroa. It will be recommended gradual replacement of conventional hives with log hives put on the ground on some short elevations to create similar conditions to bees in apiaries to this which will be offered by tree hives and 3 log hives in the forest. And then eventually gradual replacement of domesticated breeds of honeybees with wild swarms caught in the forest. This technique, which is, for instance, used by Professor Seeley in providing swarms for his apiary. And as an alternative, we can also use primitive breeds close to Apis mellifera. That way, we may eventually achieve situation that we can remove this domesticated bee avoidance zone. That means we can assume that swarms coming from apiaries are of so good quality that the swarms will not genetically or epigenetically spoil the free-living population, or rather, to contrary, that it can even improve the situation. And I have to admit here that this is not entirely theoretical example of attitude, because similar attitude is now planned by Polish State Forest in Puszcza Pilicka Forest, to promote so-called Augustowska bee and to use apiary with this Augustowska primitive breed of bee very close to Apis mellifera and mellifera to deliver swarms to these high quality swarms to the forest. The only thing which worries me is that they so far plan to treat for varroa, but otherwise the idea is very close to that what I present here. So coming back to this theoretical example, after removal of these domesticated bees avoidance zones, we can start searching for these natural holes in trees in this remaining part of the forest and adding tree hives, log hives, and that way we can assume that, for instance, within 5, maybe 10 years, we can achieve a total of 78, in this very example, available nesting sites in the forest. That means that we are already close to that ideal state, which, if replicated, and if we can add 4 similar chunks of the forest in the neighborhood, we can achieve this desired size of free-living honeybee population. We may even think about adding some of tree hives and tree log hives in farmland to have a bigger meta-population of free-living honeybees. And now final conclusions from our experience from Puszcza Pilicka Forest. The first one is that tree beekeeping can be, under certain conditions, an efficient tool for building a strong population of free-living honeybee colonies in forest. But, of course, this task will not be easy, no doubts about it. It is necessary commitment for many years and forest area large enough to accommodate about 200 tree and log hives, and this is quite a challenge. And it requires that free living colonies and colonies apiaries be recognized as one meta-population. In order to achieve that, it's necessary to establish efficient cooperation on large area between forest owners. In Polish case, this is mostly a Polish state forest, and between apiary owners, beekeepers, and nature conservationists. With fulfilling these conditions, we may achieve ultimate success, having in mind that at the same time we should focus on improving forests. And that is already happening in Poland, as tree beekeeping was adopted by state forest as a sort of non-production activity. And for instance, in this Augustowska forest I already mentioned, they are run already projects on improving conditions, like creating flower meadows within the forest, creating little ponds which can provide water for bees, adding blooming trees, linden, some wild fruit trees, etc. So it may actually really happen. It's not just a dream. The dream may come true. However, I would like to stress out one more concern, general note and concern, that honeybee, which we love, and which is endangered species, is actually also a threat to all other insect species due to unnaturally high colony densities. Apiaries, the density of colonies there trespass 10 or sometimes more than 10 times fold the natural density of colonies, which we can expect in our climate condition. And that means not only competition for food, which is obvious, but also disease transmission. For that reason, we should always remember that by increasing the number of honeybee colonies, we worsen the situation of other, often rare, an endangered species of insects like this solitary bee, which is presented on this photo. And this is an important dilemma with no easy answer how to resolve it. Thank you very much for your attention.
Thank you very much, Przemek. Very impressive work. You and Hartmut Jungius, you are the very, how can you say, in German, Urväter, the first persons of all this movement and all this work done. Very impressive. So let's just give the place for comments, questions, whatever you would like to share or to ask. I think we have a lot of knowledge here. Probably you not only have questions, probably you also have statements and something to share. Hartmut.
First of all, Przemek, thank you very much. I think this is the first time that somebody had a serious scientific look at the exercise which we have started with tree beekeeping and with the Zeitlerei. Well, what you have done is you have actually laid down the strategy for a proper reintroduction project for the wild honeybee. And I think it would be great if you would write that down and make a publication out of this, because this would be very, very valuable, not only to FreeTheBees, but also to other people who get involved in the Zeitlerei and just making artificial beehives, making log hives, making tree hives, n'importe où, with the hope to get bees back without starting with a proper analysis, in particular of the habitat and of the surroundings. And in that respect, I have a question. You mentioned in the Pilicka Forest that many hives were not occupied. Did you or the team make an assessment of the surroundings of these hives to find out the reason, where the reasons for the habitat, that the habitat was unsuitable, or that some other conditions were unfavorable, which caused that bees were not colonizing these hives, or only for a year or two?
We would like to answer this question in exactly the way you just described, but in order to do that, we need to apply GIS tools. So we planned for this fall to collect precise data on location of all these tree hives and log hives, and as well as apiaries around, to check what is the reason. Is it environment, like you mentioned, for instance, surrounding like age structure of the forest, available food, water, etc., or just distance from the nearest apiary, which can be the simplest answer why some tree hives are occupied but some not. Yeah. So this spatial analysis for us will be now very important next step, because we would like to also look at the survival of the colonies from the same perspective, to check if this wintering rate, for instance, is associated somehow correlated with the distance from the neighbor colony in a tree hive or log hive or natural hole, or from a nearest apiary, because these are the factors which we suspect in the situation of food shortage that may really matter, the competition with other bee colonies. That will be, I believe, available, if we are lucky, for next year, this part of answering the question, what influences the rate the particular sites are occupied, and what influences the especially wintering success of the bees in particular sites.
Okay, thanks.
Przemek, have you any idea what kind of number of tree cavities used to be there in the past and how many were occupied in a really natural environment? I think I saw somewhere about 10 times more cavities than what was occupied by bees, but I cannot remember the source anymore.
There are some publications on that, which indicates recently done. By the way, I think that our tree beekeeping project, especially spreading the knowledge to the western part of Europe, increased interest in free-living bees among scientists.
Yeah.
And one of the publication studied holes, cavities made mostly by woodpeckers, and how is the rate of occupation of this site by bees. And it turned out that 1 out of 10 holes initiated by woodpeckers may be used by bees. That means not bad, but as I already mentioned, it may also be sort of ecological trap, because if these cavities are created by birds, they then can be accessed by birds as well. While what is missing in our forests are very old trees, which are rotten inside, cracked, and from the perspective of bees, the safest place will be a hollow tree with access through, for instance, a crack wide enough for the bees, but too small for any predator to access. So I think that this path of research oriented only on cavities initiated by birds may lead to indicate location with very high predation pressure. I must mention that in our case, out of this 110 wintering, we can document only 2 cases of failure because of predators, and in both cases that was pine marten. While, for instance, this cavity which we found using bee lining technique was obviously started by black woodpecker. In such case, pine marten can easily access such cavity, which is used by this little predator to spend nights to prey on bees. So that means that most likely that is the reason why both these colonies which we found didn't survive winter.
There is some data from Benjamin Rutschmann and Patrick Kohl about predator pressure. It's not as bad as one might think. I was impressed. It's quite low, but there is a pressure, sure.
Oh, everything leads to the conclusion that we need more research, and one of the reference area is Białowieża Forest, Puszcza Białowieska. This is the best preserved lowland forest in Europe, protected by national park on part of it on Polish side, and the whole chunk of this forest on Belarusia side. And this is the place where we still have trees which are 300 years old or even older. We can find the right species composition. And this is the best area to look for natural cavities and for bee colonies, and to study survival, predation there. This is kind of a reference area. And I hope that such research will be done, as already scientists started to be interested in Białowieża Forest from the perspective of honeybee. So soon we will know, because this, to answer directly your question, we need to study Puszcza Białowieska first. and then compare this modern forest, either commercially used or protected as national parks, to this reference area, and to say that they have, for instance, 10 times less of cavities than Białowieża forest, or maybe only 50% less. Difficult to say.
Thank you. I guess we had Alan asking a question.
Thank you.
Sorry, didn't see before.
It's a purely practical question, I'm afraid. I have a colony of wild bees in a bit of farm machinery that I want to get them to move into a log hive, which I'm going to hang up near the machinery. But are there any tips any advice on how to attract them? They've got a very safe place in the machinery. And although I think in winter they'll die from the cold because it's metal. So I'm trying to, I want to get them into a log hive as soon as I can.
I think that here Andrea may provide an answer. I can only suggest that there is only one way to locate the colony and try to mechanically move them from one place or another, because otherwise they will not move by themselves.
Well, I mean, you can just wait for the swarm, and the best way to attract is wax. So you have to bring into your new log hive old wax. The older it is, the better it is. It smells a little bit wax, it smells a little bit of propolis, and so you can attract the swarm. And don't bring the log hive too close. You need at least 50 meters of distance, better 100 meters of distance, so you have quite a good chance of attracting your own swarm.
Okay, thank you very much.
Moving sometimes is very difficult, and if you move, you need to move, in my opinion, in spring, right before you have really all the flowers blooming with the whole nectar source. So in our places, usually at the end of April.
Okay, thank you very much indeed.
Lucia.
Two questions, but thank you very much for a most interesting presentation. That's fascinating. Could you find out what the causes are for quite a short survival rate in tree hives and in log hives? Was it lack of forage sources, or was it disease or too cold? Could you find any reasons why they only survived for such a short time? So that's the first question. And did you notice a difference between the bees from apiaries and feral bees? I could imagine that the feral bees were better able to survive than the bees from the apiaries. So I'm quite curious what you think.
The question is that the answer is that we are not sure, because we do not have comprehensive study of the situation. We do not treat the bees for varroa.
Mm.
That means that their survival may be affected by varroa in that way that they use more winter resources of honey than in the case if they were not infected by varroa. We do not have any case which would indicate that the bees died out because of any disease. In such a situation where, for instance, combs are full of honey and the bees are dead.
All right.
Sometimes it happens. it's obviously a very, very strong viral or bacterial infection. But in our case, when we have dead swarms, that means failure of wintering, there is also always associated with lack of food. That means empty combs and no swarms. And this the reason why the bees have difficulty to collect enough food for winter can be of two sources. One, the most obvious, it seems, is the simplification of forest habitat, lack of trees which bloom late in summer, like linden. Very small areas covered by heather, which was also a source of late summer food. And also, on the top of that, competition with apiary bees, what includes also possible cases of robbing honey from tree hives and log hives located closer to apiaries by bees from apiaries, which are harvested, and they are left without honey. So the reaction to that situation may lead to robbing our bees in the forest. We do not have hard proof for that, but we cannot exclude such a case. Coming back to your second question, I think that the answer cannot be given now, because we are not able to distinguish which swarm came from where, because contrary to regular hive, we cannot find the queen in tree hive or log hive. The only case which we can say, like I mentioned, that this queen came from apiary is in situation when the swarm dies, the colony dies, and we found a dead body with the badge. So at that moment, we can only guess that we may have sources, two sources of swarms, both apiary and its natural host. In order to have more precise answer of the possibility which source came from which swarm came from which source, is the more detailed information about spatial distribution of these tree hives and log hives, which I mentioned that we are planning to do. That way we may, improving also our knowledge about this natural location for honeybees, we may assume that in any particular location, the bigger probability is, for instance, for swarms from natural location, or in a certain other, the bigger is from apiary. As some experiments run in forest by bee scientists who work with artificial swarms, and they try to read what the bee scout signal about location in the forest indicates that in forest area, bees usually locate locations for settling down the colony in a radius of about 500 meters. That means that if we have tree hive within this radius, that means close to apiary, that the most likely source of swarm will be apiary. If the distance is much higher than 500 meters, that means more likely will be swarm from natural sources. So the precise answer
I understand.
is not easy, but we will work on that.
Yeah, thank you very much. Thank you.
I think that perhaps we are coming to the end of the questions. So I think that we may end our meeting with invitation to Poland. If you
Thank you.
would like to visit us one day, because it's not far away from Warsaw, 2 hours drive, we will be happy to see you and to show you our tree hives and log hives in reality, not only on the screen of the computer.
I'm very, very sorry, needed to leave 1 minute, probably the wrong one. I guess we could speak the whole night. I have myself a big list with questions, but I think we leave this up for another discussion.
No, I think that in Poland there is tradition to make miet, kind of alcoholic drink based on honey. So we can make a virtual meeting over a glass of miet and continue the discussion.
Sounds perfectly well. All right, so I mean, you all know who Przemek is. He probably might share his email address in the chat. I'm sure he answers to questions, and otherwise just write to me. I can send it over to Przemek. And Przemek, thank you a lot. Really interesting, really impressive. And I would like to thank to all the donators too, making possible our own work. And yeah, thank you. And hope to see you next time. We have once a month, we have such conferences, all of them very interesting, some interesting following. So enjoy your evening and thank you a lot.
Thank you very much. See you then.